All right, so I've said this before in this unit, factoring is the most important thing that you're going to learn this whole entire school year. So please just make sure you're following along to any of these descriptions if you're confused on anything. All right, so for the first one, x squared minus 49. I know that this one's going to have to either be GCF or DOPS because a equals 1 is a is greater than 1 are both trinomials, 3 terms, and this one only has 2. Now in terms of GCF, if I'm comparing a 1 with a 49, the only thing they'd have in common is a 1, and then the first term has an x squared, but the second term doesn't, so it's not going to be a GCF. They don't have a GCF, which means it must be DOPS, differences of perfect squares. Now to factor DOPS, you just need to take the square root of each of the terms. So the square root of x squared is x, and the square root, because you're dividing by 2, right? 2 divided by 2 is x to the 1. You just don't need to write the 1. And the square root of 49, if you type this in your calculator, second x squared is 7. And then with DOPS, your first set of parentheses is a plus those two numbers, and your second set is a minus. So this ends up being your factored form. Remember, you can always put the original in y1 and your answer in y2 and check to see if the tables match to check your answer. For the second one, there's 2 terms here, so again, it's either going to be GCF or DOPS. But one thing I know about 24 is that it's not a perfect square, 25 is, so it can't be DOPS, which must mean it's GCF. You can do the GCF by hand by listing out the factors of 16, or you can do a math arrow to the right 9 and do a GCD of 24 and 16. You just can't include the negative in that, and what the calculator will tell you is that GCF is 8. And then my GCF isn't going to have an x with it because the first term has an x but the second one doesn't. So when I'm factoring this, I'm going to have an 8, and then I'm going to do my first term divided by 8 and my second term divided by 8 in my parentheses. So 24 divided by 8 is 3, and I'll just keep the x, and 16 divided by 8 is 2. You can check this using y1 and y2 of your calculator and seeing if the tables match, or you can just redistribute that 8 and see if you end up back where you started. Number 3 is a trinomial, so it's definitely not DOPS. The first term is 1, so it's not a is greater than 1, so it's either GCF or a equals 1. I know it's not GCF because this is a 1, so it has nothing in common, and this doesn't have an x, so there's no x in common either. So this is going to be an a equals 1. So to do a equals 1, you go to your y equals screen and you take the c term and you divide it by x. And what you're doing is you're looking through the table for 2 numbers that add to 17. So let's check it out. Let's do 42 divided by x. Side by side, I'm looking for numbers that add to positive 17. So I see 14 and 3. And when I have those 2 numbers, they just go directly into my parentheses, and because they're both positive, I just do 14 and 3. So this is my answer in factored form. I could type this into y1 and this into y2 and check the tables to see if they match to check my answer. Number 4, this is a binomial, 2 terms, so it's either GCF or DOPS. And I know that 18 is not a perfect square, neither is 15, so it must be GCF. Okay, so I'm going to do a math arrow to the right, 9. I'm going to do a GCD of 18 and 15, and what you'll notice is I'm not including that negative, even though there's a negative there. You'll get an error if you include the negative. And if you type that into your calculator, you should get a 3. So I know that the GCF between 15 and 18 is 3. I also know that because the first number is negative, the GCF is going to be negative. And because there's an x to the third and an x. They both have at least one x in common. So I'll make the GCF a negative 3x. So to get what goes inside the parentheses, I divide each of these things by negative 3x. Keeping in mind that this has like a 1. So I'm going to divide negative 18 by negative 3, that's positive 6. And then I'll subtract the exponents, 3 minus 1 is 2. I'll have plus, but 15 divided by negative 3 is negative 5. So instead of writing plus negative, I'm just going to write minus. And then these x's actually end up canceling out because 1 minus 1 will give you 0 x's. So this is my factored form. You could check this by putting this into y1 and this into y2, or by redistributing that GCF. Number 5 is a trinomial, but the leading coefficient is not 1. So this is going to be an a is greater than 1 problem. To do a is greater than 1, the first thing we do is a times c. So the first number times the last number, which is negative 20. And then I'm going to go to the y equal screen and I'm going to do a negative 20 divided by x. So basically I'm looking to find two numbers that add to negative 1. So I'm going to do a negative 20 divided by x. And I'm looking side by side for two numbers to add to negative 1. I actually opened up right on it with negative 5 and positive 4. So what I'm going to do is I'm going to split up the negative x into negative 5 and positive 4. It makes more sense for me to pair the positive 2 with the 4 and to pair the negative 5 with the negative 10. Those seem like a more reasonable pair because 5 and 10 are easily go into each other and 4 and 2 easily go into each other. So once I split that up, I break it up into groups of 2 and I need to find the GCF. Okay, so the GCF between 2 and 4, you can either do like a math arrow to the right 9, or maybe you just know that they both go into 2. And since I have 2 x's here and 1 x here, they have at least 1 x in common. And then 5 and 10, their GCF is 5. You could do a math arrow to the right 9 for that, because the first term's negative between those two. Yep.
I can't remember what you said. I realized I should probably go for a walk.
I'm going to go for a walk in like 10 minutes.
Yeah?
Yeah. Do you want me to come get? Yeah, I'll come down and get you.
Alright, 10 minutes is good.
Alright.
Because I probably have stuff to do. I still feel like doing it. Oh,
Yeah.
yeah, give a test.
You should grade that.
No, not yet. I should grade that. Alright, yeah, I'll go do that.
Alright, cool.
Alright, cool.
Sorry for my side note there, guys. Okay, so because the first number is negative, I'm going to make the GCF negative. Now, I'm also not going to put an x for both of them because that 10 doesn't have an x. So, when I divide out a 2x, it has to go to the front. And this is kind of like a 1, so I'll subtract. So, 2 divided by 2 is 1. I don't need to write that 1. X, and then I subtract 2 minus 1. That's a 1, but I don't need to write that 1 either. 4 divided by 2 is 2. And then these x's here cancel out. And then when I take a negative 5 out, I have to put a negative 5 here. And negative 5 divided by negative 5 is 1, but I don't have to write the 1. And x divided by, there's no x, so I'll just keep the x. Negative 10 divided by negative 5 is positive 2. I know I'm right because the parentheses match. So my final step would be to take my GCFs and write them as one factor, and then my x plus 2 and write that as my other factor. So my final answer is 2x minus 5 x plus 2. And I could check that in y1 and y2 if I wanted to. My next one is a trinomial. There are 3 terms here, but the first term doesn't have a number in front, so it's like a 1. So this is an a equals 1 problem. And to factor an a equals 1 problem, you go to your y equals screen and you take your c term and you divide it by x. And I'm looking for things to add to negative 14. So I'm going to do a 48 divided by x. And side by side, I'm looking for something to add to 14. So negative 14. Let's see. 6 and negative 8 add to negative 14. So they're both negative, so I'll just put x minus 6, x minus 8, and with the a equals 1 method, that's the only thing you have to do. You could check this with y1 and y2. See if your tables match. Okay, at first instinct, I want to say that number 7 is an a is greater than 1 problem. However, one thing that I noticed that's standing out to me is that this is even, this is even, and this is even. So my guess is there's a GCF that can be pulled out here. If you do a math, arrow to the right 9 of 2 and 28, you'll get 2. And then if you do a math, arrow to the right 9 of that GCF 2 and 64, you get another 2. So I actually can divide 2 out of all of these numbers. So there's a GCF here. And if I divide 2 out, it doesn't go away. It just goes to the front of the parentheses. But now what I have inside is a trinomial where the first term is a equals 1. So this actually is GCF, and then that GCF turns into an a equals 1 problem. So with this stuff here inside, I'll do a y equals negative 32 divided by x, and I'll see if anything on my list adds to positive 14. So I'm looking for a positive 14, and I see negative 2 and positive 16. And with a equals 1, that's all I need is a negative 2 and a positive 16. Just don't forget that that 2 you factored out in the very beginning belongs in the front of your answer. For this next one, I see 16 and 121. It's a binomial, but I also know that 16 and 121 are both perfect squares. So this is going to be a DOPS problem. I'm going to take the square root of 16x squared and the square root of 121. The square root of 16 is 4, and the square root of x squared is x. The square root of 121 is 11. And with DOPS, you're just keeping the parentheses the same but opposite. So I'll put the 4x in both the first places and the 11 in both the second. And this problem is done. For number 9, it looks like it's going to be an a is greater than 1 problem. I would check for a GCF, but I know that 23 is a prime number, so I'm not going to be able to divide anything out of that. So I'm going to start with my a times c, and that's 6 times 20, which is 120. And then I'm going to go to my y equals screen, and I'm going to do 120 divided by x, and I'm going to look for things that add to negative 23. So 120 divided by x, and that was positive, right? Yes, and I'm looking for things that add to negative 23. I think negative 18 and negative 15 add to negative 23. Sorry, negative 8 and negative 15. So I want to take this and I want to split that up to negative 8 and negative 15. It makes more sense for me to pair the 6, I guess, really with either. So I'm going to do the negative 8. And then I like pairing the 15 and the 20 together. Okay, so I'm going to pair it like this. And I'm going to find the GCF, so you could do like a math arrow to the right 9 of 6 comma 8. And I know that I can divide a 2 by both of them, and they both have at least an x. So I'm going to take a 2x out. 6 divided by 2 is 3, and then when I subtract 2 from 1, I get 1, but I don't need to write that 1. Negative 8 divided by 2 is negative 4, and these x's cancel out. Negative 15 and 20, if I do a GCF between 15 and 20, I know that I can divide them both by 5, but because the first term is negative, the GCF also needs to be negative. It can't have an x with it because this 20 doesn't have an x with it. So I'm going to divide out a negative 5. Negative 15 divided by negative 5 is positive 3, and I'm just bringing that x. 20 divided by negative 5 is negative 4. I know I'm right because my parentheses match. So I'm just going to write these two things together. And then that repeated 3x minus 4 together to get my final answer. All right, for the last one, it is a binomial, so it's either GCF or DOPS. And what I notice is that 3 and 27 both aren't perfect squares. So I'm going to do a GCF here. I'm going to do a math, arrow to the right 9, and I'm going to do a GCD of 3 and 27, not including the negative, and I get a 3. So I know that the GCF is just 3 because I can't have an x because the 27 doesn't have an x. So I'm going to divide 3x squared by 3 and negative 27 by 3. So I end up with x squared minus 9. Now the trick to this one is when I see something like a 9, I'm always thinking that it could also be DOPS because these two numbers are a binomial and they are actually both perfect squares. So from here, I can do the square root of x squared and the square root of 9. And with DOPS, you have two sets of parentheses, one with a plus, one with a minus. So the x will go in the first spot and the 3 will go in the second. But then that original GCF of 3 goes in the front. So this was a double factoring problem. Hopefully this helps. At this point, you can also finish the entire Math Excel. So I want you to use class time to work on that now.